First, it's a pleasure for me to present in the DevFest Ahlen, and I really want to thank Anna for this opportunity. And also, I wish that everyone who is here to have a good time with me. So, my name is Asma. I am a PhD student in artificial intelligence, and also I am a backend and AI developer at DeepMinds and one of the organizers here in GDG Stif, Algeria. Today, I want to talk about something that has absolutely transformed how I approach research, and I believe it can do the same for you, which is Keras. So, whether you are building computer vision models for medical imaging or developing NLP systems, the Keras is very important for those things. So this is a hands-on workshop, which means that we are covering both the theory and the practical insights that we need. In this presentation, what we are going to explore, four important cases. The first one is why Keras is the go-to choice for academic researchers, which means why we choose Keras. The second is how to integrate into the typical research workflow from the workflow is from hypothesis to publication. The third is the architectural foundations that make rapid prototyping possible. And fourth, which is finally, is the practical strategies for the advanced data pipeline, training callbacks, and rigorous model evaluation. Okay, so why Keras for research? Well, in the research space, we have a lot of options. We can, for example, use PyTorch or anything. It's also powerful, but the question is why we use Keras or what makes Keras special. It's for four reasons, four or five reasons. The first one is that Keras is high-level API built on the top of TensorFlow. This means that you get all of TensorFlow's computational power without a long code. And instead of managing sessions and the placeholders and the complex tensor manipulations, we can work with a clean abstraction, less code to debug, and more time for actual research, because the point in research is to find the new contributions and the new ideas. The second is that Keras is very speed, so it enables a fast transition from idea to experiment to the paper result, which is very important in the academia. The third reason is that the code is clean and self-documenting when we are collaborating with advisors or the ones who are writing in the thesis. And for the fourth reason is the community. There is a huge community in Keras, so if we have like errors or bugs, we are not alone. And finally, the advanced features. Keras gives a native support for the things researchers actually need, like the custom training loops for novel loss functions, the multi-input and multi-output models for the fusion architectures, and also the integration with explainable AI, which is a trend, and explainable AI is the technique that makes the models be understood by the experts. So we can trust those models. So in short, Keras is designed by researchers for researchers, and it's built for exactly what we are doing. So now Keras in the research pipeline. This is the typical research workflow. Each research follow when we do our researches. So we follow like 7 steps. The first step is the hypothesis formation. So this is the start. We we like put a question. For example, do vision transformers outperform CNNs for colon cancer detection? I give the example for colon cancer because actually my research is based on, is typically on the healthcare, and I'm working on colon cancer detection. So this is the first thing. We have to ask the question. Then the step 2 is the dataset pre-processing and labeling. So after we gather the data, we clean it and we label it. For example, if we are working with the LC to 25,000 or any internal dataset, imagine. This is example of the dataset. So this step is really time consuming because it's in the dataset we have like a huge or large dataset, so it's gonna take a lot of time. So when we use Keras, this can help us in this step, so it's not going to take a lot of time. The step 3 is the model prototyping with Keras. So here we need to choose the model. So we translate the hypothesis that we put at the first step into an actual architecture. So we are going to ask if we need, for example, a simple CNN baseline, or a vision transformer, or maybe we need like a hybrid model, so we can do with both. And then the Keras helps us to build this model, test it, and also iterate it very fast. The step number 4, which is very important, is the ablation and architecture comparison. This is important in research because it's not enough just to, in the research, to just put or to just develop and build the model, but we have to do the comparison. This is mean what's the new model or what's your proposed model comes to, or what is the result. So in the ablation, what we do, we remove, for example, a layer and change, for example, activation function, and put all the results to do this comparison. In the fifth step, we do a statistical evaluation. Here we compute metrics, accuracy, precision, recall, F1 score, and we can also run statistical tests like MC-Neymar's test. This is to confirm if our results are significant or no, and all of those we can do it using the Keras. The step number 6 is the visualizations and the interpretation, and this is to go through the importance and the significance contribution in our model. So here we create visualizations, and we can also generate attention maps with LIM, which is an explainable AI technique. And here in this step, we can prepare we can make the publication ready figures using the visualizations. And finally, we can go through the manuscript preparation, and we can start writing after doing all those things. So why does Keras fit perfectly here, this research workflow? Because it like gives us minimal code. We write less, but we do more. And also we have like less debugging, more research, because we need the time for research, as I have mentioned, and to find like a new contribution. Also, it's very rapid architecture iteration. And also it's a clear experiment traceability. Okay, now that we understand the why and we mention why we use Keras in research, we can go through the Keras architecture internals. So at the heart of Keras, we have 4 fundamental concepts. We have the layers, the models, the optimizers, and also the functions. So what is layers? A layer encapsulates both states in the trainable parameters like weights and biases and computations. So when we write like a dense 128 and activation function like ReLU, We are here creating a layer with specific state and computation rules. The second is the model, which is directed acyclic graph of layers with the trainable parameters. This is a container that orchestrates how layers connect and interact. And in Keras, a model is callable, so we can always call it, and we can just pass the data through it like a function. So it's easy for in implementation. The third thing is the optimizers. What are the optimizers? The optimizers defines the gradient update rules, like we have, for example, Adam, SGD, or Adam W. The choice impacts the convergence speed and the final quality, and those depends on the data sets we are using. Also, Keras provides like proven implementations of all the major optimizers. The fourth thing is the loss function, in which we are minimizing and the categorical cross trompery for classification. We have the MSE for regression and the custom losses for specialized problems. For the loss function, we can use it when we talk about the evaluation of the model, because when we have a small loss value, so that means that our model is good. So, and now what we have like, we have to know that Keras supports the two execution modes, the eager execution, which is by default, and we have also the graph execution, this through the TF function for performance. Okay, we have to know the difference between them. So for the eager execution, here the code runs line by line immediately, so it's fast. And this is really perfect when we want to debug and for the interactive exploration, because we can see the outputs right away. Whenever we do the run, we can see that. And for the graph execution, when we use the TF function, so this converts the Python into like an optimized computation graph. So this mode is more fast than the first one. It's provide like raw performance. It's as I said, it's much faster for the production. And yeah, so those two are very important for research debugging uh, and optimization. Okay, now what we are going to see, we are going to see the difference between, because those are the types, between the sequential and functional and the subclassing API here in Keras, and what is the best for us as researchers. Okay, so Keras provide us three ways for defining the models we have talking about. And for sure, one has its advantages and its cons. The first one is the sequential API. So it's fast to write and easy to read, and also it's perfect for the simple linear architecture. So it's only for basic or simple tasks, but it only works for sequential architectures. What does this mean? It's skip the connection or multiple inputs. So if we have like multiple inputs and outputs, we cannot go through this sequential API. So we use it just when, for example, we build like a simple image classifier, and it's good for quick prototypes. The second one, which is the functional API. So the functional API, this is what most researchers use, and it's for a good reason, because it's flexible and explicit. In the functional API, we can now use the when we have a multi-input, we can use the functional API. And the last one, which is the model subclassing, this this for the customized, it's for the novel architectures that don't have or don't fit standard patterns. We can like a subclass model and override the call method, and this gives a complete control. The advantages of the model subclassing, it's maximum flexibility and required for novel architectures, but is less static graph inspection, and for the visualizations it's really hard, and it's required more complicated codes, not like the sequential API and the functional API, which just require simple codes. Now let's move to the advanced data pipelines with Keras. So it's one of the most underrated aspects of Keras. It's data pipeline architecture. It's handling data efficiently. That can be the difference between training a model in 2 hours versus 2 hours. So Keras uses the TF data API under the hood, as we have mentioned, and understanding it is very important for research. We have three key features. So the first one is the streaming dataset. So instead of loading the entire dataset into RAM, tf.data streams data directly from disk to GPU. So for medical imaging datasets, which are often gigabytes, this is very important because we are not going to be limited by the memory size. The second thing is on-the-fly augmentation. So here we can apply data augmentations like rotations, crops, color shifts during the training without storing augmented copies on disk. And for sure, this will save the storage space and ensure that we slightly different augmentations for each epoch and better than generalizations. The third thing is that it's very efficient GPU pipelines. The pipeline prefetches data from disk while the GPU is training. By the time the GPU finishes a batch, the next batch is already loaded and already. So this will help us. And why does this matter for researchers? Because let's imagine that we are working with thousands of high resolutions for the colonoscopy images without an efficient pipeline. Here the code may crash, the session may disconnect, and also the training is going to be really slow because the data is going to be read from the disk. And also the augmentation requires storing multiple copies of each image. So each image must have copies. So this is may make the disk explodes. So with the TF data, we can handle all those, and we can for sure make the training fast. For the baseline, which is the MLP, this is very important because it improves the research best practice that many practitioners overlook, the importance of the baseline model. So why we choose the MLP? The MLP, which is the multi-layer perceptron, this is the simplest neural network. It's fully connected, and we have no special structure, no inductive biases. It is simple, and yeah, that's what we need. Okay, let's give an example. Okay, let's imagine that the proposal model we proposed, which is, for example, a vision transformer for colon cancer detection, with VIT gets 98% in accuracy. This is like really impressive results. But what the reviewers will ask, they will ask how much of the performance comes from the VIT architectures comparing to just having like a really big model. So here we need to use a baseline model like the MLP. We are going to train an MLP baseline on the exact same data, which is going to achieve 92% accuracy. So now we can claim with confidence, and we can say that our VIT's model provides like a 6% accuracy improvements. And this is really the scientific contributions. So Like in more generally, what we can say about the baseline models, we can say that baselines models can help in quantify the benefits of any architecture. Models ensure the fair comparisons and also establish like performance floors, and this is very important in scientific evaluation. Now we have focused mostly on image models, but the Keras, in fact, equally powerful for sequential data, and that's why we want to talk about RNNs and LSTMs. So for the RNNs, that are the recurrent neural networks, they processes sequences. What they do, they are natural for several use cases like text classification, because they do the process in text word by word or maybe character by character. Also, it's useful for the time series analysis, like stock prices or sensor data, anything with temporal dependencies. And also, it's useful for biomedical signals like ECG and ECG and ECG signals. Those are useful and required in the health. Why we use LSTM? Um, they solve the vanishing gradient problem with a clever getting mechanism, because they forget gates. They have forget gates which controls what to discard from memory. They have the input gate that controls what's new information to add, and the output gate to controls what to expose to the next layer. For the LSTMs, Keras provides them for battle tested implementations optimized for both the CPU and the GPU. We we just we don't need to do the whole implementation. We just need to write some little code like model add, because we have like predefined functions. So the implementation for them is really uh, easy. Okay, now let's imagine that, okay, we have built the model, and now we are going to the important question, which is how do we can train it properly after suggesting the model. So here what we need the Keras callbacks, so we can call the functions. The callbacks are some functions that run at specific points during training. We have early stopping. Early stopping, this is useful to avoid the overfitting, because when we have at some point in the training the same results in validation, when we use the early stopping, we can stop, because it's we actually get to the good result, so we don't need more runs. It monitors validation loss and also stops the training, as I told you, if it hasn't improved for the epochs. The second callback is reduce LR on plateau. So this is reduce the learning rate when the validation loss its plateaus. And the third one is the model checkpoints. This one is very important because it saves the model weights to disk after each epoch. So we can always save the best results for the model when we train it. So now I'm going to share with you a workshop preview, so a code, and we try to understand it. So okay, so here we are going to explore the Keras like for prototyping in AI research. The goal, as I mentioned, it's not just to run models, but to think like researchers to find the best contribution and the best results. Okay, so the first thing is that's here in the machine learning, the randomness, it's everywhere, like weight initializations or data shuffling or dropouts. All of those things are random. So here we fix the seats for Python, NumPy, and TensorFlow. This is to ensure the reproducible experiments. What we mean by the reproducible experiments is that when we use this code again for the same data, we should have the same results. And this is like something mandatory in the research. Without it, like results cannot be scientifically validated. Then for the visualizations utilities, here we create like a reusable plotting function. This is a function for plotting, and this function is to track training and validation curves. So just when we finish training the model, we can just call it and see the curves. Why the curves? The curves, when analyze the curves, we can know if our model is overfitting or underfitting or unstable training, so we can improve it by changing the parameters, because as I told you, it's random. Then this phase, which is for data loading and pre-processing. So here we use the MIST as dataset because it's already exists here in Keras datasets. And we also prepare here like two versions of the data, flattened for the MLP, because for the MLP we need a flattened one, and structured for CNNs. We are going to try both both of MLP and CNN. Okay, so here we should do the normalization for the CNN and this for the MLP. Okay, now this is the baseline model, which is the MLP. So this is the starting point that we should always do it. It's a simple multi-layer perception. We need it just to know if we are improving or not. So for this architecture, we have put in layers from, for example, here 256 to 128 units. We use the ReLU activation function and also like a final softmax, a final softmax dropouts with 0.3. Okay, this one is against the overfitting. We always try to use it, so we avoid the overfitting. Okay, we have using the MLP because it's ignores the spatial information. And here is the results. We just used 10 epochs, or I think 9. Yes, 10. Those are the results. Those are the curves. We just called the function that we have already defined it here, the plots. This is the function, and now we called it here. So we can analyze the model. And this is the CNN. So basically, CNNs are always designed for images because they leverage the local correlations and they detect patterns. So CNNs are very good for images. In this architecture, what we used the conv2D, which those are the layers. The pooling reduces because also we use the batch norm, the max pooling, and yeah, again, we draw. So here we can do the analyze between those two models. And okay, for the last one, This is the functional API, and this is no, not this one. Just a second. Okay. Yes. So for this, the sequential API allows the branching and merging layers. For example, here what we built like branches 3 multiplied by 3 and 5 multiplied by 5. So it depends on what we want for the architecture. So we need to try, and then we compare the results with the baseline we did before. And this last one is for the LSTM. So the LSTM needs to have like embedding layer maps. It captures the long-term dependencies. We put here the dropouts for reducing overfitting, and the dense layer that outputs sentiment probability. Okay, so this is demonstrates that Keras flexibility, it's the same framework that can handle images, sequences, or other modalities using Keras. And in research, the ability to rapidly prototype across data type is really important. So yeah, that's what we need to do in the research. And Keras make it very easy, as you said. As you see, the codes are very easy. And from those points, we can go through our contributions. So, okay, I can share with you the link of the code. Yeah, and like that, I think I have finished the presentation. So yeah, if you have any question.
So we haven't question in chat, just a question from me about link which is sharing. Can I share this link after in description under recorded video? And
Yes, for
to share other links which you think will be helpful. Maybe how to start with Keras.
okay, so you need me to like share the presentation or like a tutorial, for example.
Tutorials, better tutorials.
Okay,
Free tutorials, because I know, for example, Coursera has tutorials, but it's not free.
yes. Okay, in fact, I didn't watch like a tutorial to start Keras. I just try always to build models, but I can search for that. This one, it's gonna be helpful also.
Okay, perfect.
Yes.
So if you finish, can I maybe I can stop recorded video? Yes.
Yes, I have finished.
Okay. I just opened your link. So I stop